for standard scores. Standard scores are also known as z-scores. Okay, now the rule for it is quite easy. It's the standard score, or z-score, is the actual score minus the mean divided by the standard deviation. Okay, now you can be asked to find the standard score, or even the actual score, even the mean or the standard deviation. So just use the solve function on your calculator if that happens. Janine scored 82 in a physics exam, 78 in a chemistry exam. The physics, the mean is 62, the standard deviation is 10. The chem, the mean is 66, the standard deviation is 5. Part A wrote both results as standard scores. Okay, so let's do part A over here. Let's do physics. So the z-score, standard score, z-score is the actual score minus the mean divided by the standard deviation. The actual score for physics is 82. The mean for physics is 62. Standard deviation for physics is 10. So 82 minus 62 is 20. 20 divided by 10, 2. Let's do the chem. Again, z equals x minus x bar divided by the standard deviation, which is going to equal, for chemistry, the chemistry score, 78. The mean for chemistry, 66. And the standard deviation for chemistry is 5. So when we do that one for chemistry, we get 2.4. Part B. So we've written both as standard scores. This is physics. This is chem. Which is the better result, and explain your answer. Okay, well, the better result, now remember, the positive, they're both positive, positive 2 and positive 2.4. The positive means that from the mean, it is higher. The 2 means 2 standard deviations away, that's the physics. And the 2.4 means 2.4 standard deviations away from the mean, and that's the chemistry. So the chemistry one is actually higher than the physics one. So which is better? Chem is better as it is above mean more. Example 2. A student's standard z-score for her exam is -1. What does this mean? Well, it means that she finished in the bottom 16% of the students. Why? Because remember, 1 is the 68%, 1 standard deviation away from the mean. So there's the mean, okay, and 1 standard deviation away is 68% there, which means there must be 16% here and 16% here, because remember this ties into the other one. So -1 is this part here, bottom 16%. Converting the standard score into actual scores. Now, I don't use this rule, I just use the rule z equals x minus x bar divided by the standard deviation. Okay, and then you can solve on your calculator, or you can do it theory way. A class test out of 50 has a mean of 34, so I'm going to write that down, and a standard deviation of 4, that is a mean of 34. Now let me just rub that out. And the standard deviation equals 4. Joe's standard test mark is that. What was Joe's actual mark? So we're looking for the x. So z equals x minus x bar divided by the s. He's got a -1.5. His x is what we're looking for. The mean is 34. The standard deviation is 4. Now we can just solve this for x on our calculator, and we get x equals 28. Can be done theory. So -1.5 equals x minus 34 divided by 4 times by the 4. So -1.5 times 4 equals x minus 34. -1.5 becomes -6 times 4 is that. And so x will equal -6 plus 34, which means x equals 28. Get confused, just do it on the calculator way. Now I'm just going to talk about population and samples. Population we're talking about, for example, all of Victoria, or in our case, all of the school. A sample is just a part of the school, for example. It has to include every students from year 7 to 12. Can't just include year 12 students or year 11 students or year 7 students. It must include a number of students from each year level. Okay. Now I'll let you read this. There have never been any questions on this, so just be aware of that.